Welcome to Lesson 5.2. Today we're going to use equations to represent situations. Our learning objectives of being able to write addition and subtraction phrases as single variable expressions, being able to write multiplication and division phrases using single variable expressions, being able to write single variable equations from verbal models, and being able to model real-world situations with simple equations. Here's our real-world problem. Go ahead and read through that before moving on. So an expression shows how numbers and or variables are connected by operations, such as addition, subtraction, multiplication, and division. Notice in the examples that an expression does not have an equal sign. This is because the value of the variable in each expression can change, or you can say that we can evaluate an expression using different given values for the variable. So 3 of the expressions above include variables, such as x, a, and z. So we've got 50 minus 2, 4 minus a, 12z, and 4x over 3. So these 3 all use variables. This one doesn't. So it doesn't necessarily have to have them, but it can. An expression that includes one or more variables is called an algebraic expression. Each variable in the algebraic expression can have a different value. Once again, you will not see an equal sign with an algebraic expression. We can use algebraic expressions to represent words or phrases. Often in word problems or in other situations in math, you will be given a set of words or a phrase that you will need to rewrite as an expression. When you do this, you will be looking for words that mean different operations or things in math. This way, you can write an expression that correctly represents the words or phrase. So we're going to start by looking at addition and subtraction phrases. So take a look at this chart. We've got addition expressions like 1 plus a, 2 and b, 3 more than c. So we got 1 plus a, 2 plus b, 3 plus c. Subtraction expressions, we got 4 less d, so 4 minus d, 6 less than g, g minus 6, and h fewer than 7, 7 minus h. The bolded keywords in the phrase above provide clues about whether or not you should write addition or a subtraction expression. While keywords can be a helpful guide, it is important not to rely on them totally. It is always most important to think about which operation makes the most sense for a particular situation. So Abdul has $5 more than Xavier has. Let X stand for the number of dollars Xavier has. Write an algebraic expression to show the number of dollars Abdul has. So more, we looked at the last slide, that means plus. That's an addition problem. And if X is how much Xavier has, if we have 5 more than that, we would write X plus 5 to show how much Abdul has. Now we have 6 less than a number. Okay, so a number is our variable. We can use anything we want, but for now I'm going to use n. When we have less than, that tells us it's going to be the number minus 6. So if you remember that from the table, less than means the first one is subtracted from the second. Leon is X inches shorter than Hannah. Hannah is 65 inches tall. So write an algebraic expression that shows Leon's height in inches. So if Leon is shorter than Hannah, we're going to want to take Hannah's height of 65 and then subtract from it X, because we want the number for Leon to be smaller than Hannah's, so we want to take 65 minus X. Go ahead and pause the video and write an expression for all 3 of these. Use n for your variable and then hit play and see how you did. So for a number plus 5, you should have n plus 5. 6 more than a number should be n plus 6. 15 less than a number should be n minus 15. So just like we wrote addition and subtraction expressions from words or phrases, we can also write multiplication and division the same way. Once again, we can use keywords to help us with this. The more familiar you become with the keywords that identify multiplication and division, the better you will become at writing expressions. So again, we've got a bunch of examples of keywords for multiplication. 9 times k is 9k or 9 times k. Twice as much as k is 2k or 2 times k. For division, 8 divided into n groups is 8 over n. Q shared equally by 3 people is q over 3. Half of r is r over 2. 1/3 of p is p divided by 3. So again, the bolded words in the phrases above provide clues about whether we should multiply or divide. Remember, keywords can be helpful, but you should always think about which operation makes more sense for the given situation. So if we have 3 times a number, t, okay, so you tell us times, that means multiply. So we would say 3t, or 3 times t. Mr. Warren separated 30 students into n equal groups. Write an expression to represent the number of students in each group. So they separated into equal groups. That is division. So we're going to take 30 students and divide them into n equal groups. So each group is going to have 30 over n students. Go ahead and pause the video. Write an expression for these 3 problems. Use n as your variable, and then hit play and see how you did. So for 4 times a number, you should have written 4n. For 16 divided into a number of groups, 16 divided by n. And the product of 5 and a number, we would write that as 5n. So now we're going to write single variable equations from verbal models. So what's the difference between an equation and an expression? Well, an expression is a phrase without an equal sign. That means the variable in the expression can be changed and the expression can be evaluated differently. An equation has an equal sign. Therefore, one side of the equation is equal to the value on the other side. So the same keywords that help you write expressions can also help you write equations. So here's some additional keywords that you might find helpful. So for addition and multiplication equations, you could say how many together, how many in all, or how many total. For subtraction, you could say how many more, how many fewer, how many left, or how much change. And for division, they would say how many in each. So now we're going to write an equation for 4 times a number is 12. So 4 times a number. Times means multiply, so I'm going to say 4 times n. The word is tells you to do equals. And then they're given the number 12. So 4 times a number is 12 would be 4n equals 12. For our next example, we have 7 less than a number is 14. So 7 less than a number. Less than means subtract, so a number minus 7. Is means equals, and then we've got 14. So 7 less than a number is 14 would be the same as n minus 7 equals 14. Go ahead and pause the video, write an equation for these 3 verbal phrases, use n as your variable, and then hit play and see how you did. 6 and a number is 20, and by itself just means plus, so n plus 6 equals 20. 18 divided by a number is 3, 18 over n equals 3. And 5 times a number is 25, 5n equals 25. So Kelvin has twice as many stamps in his collection as Murray has in his. If Kelvin has 60 stamps in his collection, write an equation to represent m, the number of stamps in Murray's collection. So Murray has m stamps, and Kelvin has twice as many. So we're going to take the number for Murray and multiply it by 2. And that should be equal to the number that Kelvin has, which is 60. So the equation that we would write here is 2m equals 60. Carrie made 3 liters of lemonade for the party. After the party, she had 0.5 liters of lemonade left. So we're going to write an equation to represent n, the number of liters of lemonade that guests drank. So she started out with 3 liters. And then at the end, she had 0.5. So that's going to be at the end is 0.5 equals. Okay, and they drank n of it. So they started off with 3, and then they drank n. So we're going to write that as 3 minus n is equal to 0.5. Here's the end to the beginning problem. Make sure you read that before moving on. So to review, keep in mind the key terms from addition, subtraction, multiplication, and division when translating words into expressions. When a number is talked about in a problem, it should be represented with a variable in an expression, and expressions do not have equal signs. An expression shows how numbers and/or variables are connected by operations such as addition, subtraction, multiplication, and division. An algebraic expression that includes one or more variables. Okay, an equation is a mathematical sentence with an equal sign, and a variable is a letter that represents a number.